In this video tutorial, we will discuss how to acquire, analyze, and present measurement data using LabVIEW. Additionally, we will export data to Microsoft Excel for other application needs, such as storage. This is the final step in creating an instrument control application. Previously, we have set up and configured our hardware and software and installed the necessary instrument drivers. We are now ready to use LabVIEW to program our instrument control application. In this demonstration, I'm going to use two instrument driver example programs to generate and acquire a waveform. I will then perform an analysis on the acquired waveform, write the data to a Tdms file, and view the data in Microsoft Excel. I am generating the waveform in the above example using my Tektronix arbitrary waveform generator. I am acquiring the waveform in the below example using my Tektronix oscilloscope. Both of these programs are example programs that were installed with my instrument drivers. The Waveform Generation Vi is capable of generating multiple types of waveforms, as you can see from this drop-down box. I can generate a sine wave, a square wave, or any other type of waveform that I choose using this drop-down box. By going to the block diagram, by going to Window, Show Block Diagram, or using the shortcut Control-E, I can see that this VI simply initializes, configures, and outputs a waveform. For this example, I will accept the defaults so that I can generate a simple sine wave at 1 kHz. The Waveform Acquisition Vi similarly is configured to acquire any analog waveform. This VI allows you to configure multiple aspects of your instrument, including vertical range, probe attenuation, vertical offset, and triggering level. You can see from the block diagram, while it has several sub-VIs, it essentially initializes, configures, and acquires the waveform, then checks for errors. To perform an analysis on my signal, I will add an Analysis Express VI called the Tone Measurements VI to my program. This VI is located on the Functions palette at Express, Signal Analysis, Tone Measurements. When the dialog box opens up, I will choose to perform an amplitude and phase analysis. My configuration is now complete, so I will click OK to return to my block diagram. Additionally, many instrument control applications involve writing data to a file, so I'm going to modify this Acquisition Vi to do just that. I'm going to add the Write to Measurement File Express Vi to this program. This VI is located on the Functions palette under File I/O, Write to Measurement File. This dialog box then pops up, making writing to your file very simple. In this example, I will write to a Tdms file. The Tdms file format was created by National Instruments and is specifically designed to exchange data between National Instruments hardware and software. The Tdms file stores your waveform data in a binary format and also stores your waveform properties. Tdms files provide high accuracy for floating point numbers, take up less space on a disk, and allow you to stream data very rapidly. Lastly, by installing the TDM add-in for Microsoft Excel, you can view and save your TDMS data as an Excel file. This add-in is available free of charge at ni.com, and it supports Microsoft Excel 2003 and higher. The simplest way to find it is to go to ni.com and type TDM Excel in the search box. For the sake of simplicity, I'm going to save my TDMS data to my desktop and call my TDMS file My TDMS Data. By clicking OK, my configuration is complete. I am now ready to wire everything together. You may be wondering what these functions are that LabVIEW placed on the block diagram when I wired my data to my Express VIs. These are called Convert to Dynamic Data functions. Express VIs have their own dynamic data type. LabVIEW, by default, places this function on the block diagram when an Express VI is wired to a non-Express VI to perform this conversion for you. To maintain proper programming practices, I will wire error clusters through my Express VIs. I can also right-click on my VIs and choose View as Icon to make them appear smaller on my block diagram. Now that everything is configured and positioned properly, I am ready to run my programs that will acquire, analyze, and present my waveform. I will run the Waveform Generation Vi first, and then my Acquisition Vi. You see that my oscilloscope measured roughly 0.98 volts in amplitude with about a 36-degree phase shift. Now I will open Microsoft Excel to view my TDMS data. To import my data, I'll go to Add-ins and then the TDM importer icon. I will now browse to my Tdms file on my desktop and open it. Excel will now open a new Excel file that contains two tabs, one of which contains all the properties of the waveform, including the root name of the file, the author, and the length of the data. The second tab contains all of the data itself. I will now create a graph from the second column of this sheet, which contains all of my voltage data, by going to Insert, Line Chart. You can see from this graph that the data is the same as that within the waveform chart in LabVIEW, a simple sine wave with an amplitude of 1 volt. Now that you've finished this series of Getting Started videos, go ahead and develop your skills further by applying what you've learned to your specific application. Should your application require a deeper level of programming ability within LabVIEW, you can always sign up for the LabVIEW training courses covering everything from LabVIEW Basics to Advanced, and specialty courses designed specifically for instrument control in LabVIEW. For more information on training courses offered by National Instruments, please go to ni.com/training. For support-related questions, feel free to go to ni.com/support. Thank you for watching.